Welcome to our review on efficiency. When we're talking about the efficiency of a device, what we're looking at is how good they are at transferring energy between the stores that do the job we want. So a more efficient device is better at transferring that energy. And a good example is good old light bulbs. So we used to have the incandescent light bulbs like the one on the left there. And now, more and more commonly, we're seeing the LED light bulbs like the one on the right. And what we find is the more efficient version of our light bulb is the LED. When we're talking about efficiency, there is an equation that we need to learn in order to work it out. And the efficiency is the useful output energy divided by the input energy. Now, normally we express this as a percentage, so you then multiply that answer by 100 to give it as a percentage. The kind of question they could ask you about efficiency is given here. A lamp has an input of 100 joules, the output to light is 60 joules, and the output to heat is 40 joules. Calculate the efficiency of the light bulb. So the first thing that we do in any calculation question is highlight, underline, circle or jot down the key bits of information from the question itself, which I've done in red for you. Then we need to consider what the actual purpose of the light bulb is. And hopefully that's a bit of an easy one for you. It's to give us light. So our useful energy is light, and therefore heat is a wasted energy. We don't turn on a light in order to warm ourselves up, so heat is wasted. Therefore, when we come to work out the efficiency, which is our useful output energy divided by the input energy times 100, it's going to be our 60 divided by 100, and then we times that by 100, which gives us 60%. Another example of a question we could be asked is here. A 100 watt filament lamp transfers 100 joules each second, but is only 10% efficient. Calculate the wasted energy. Because we're talking about a calculation question, the first thing we do is highlight, circle, underline or jot down the key bits of information, which I've done in red for you there. Then we need to rearrange our equation. So we know efficiency is the useful energy output divided by the total input, but we need to know about the output energy this time. So output is efficiency times by the input. So we know that it is 10% efficient, so we could do that as 10% or 0.1 if you prefer, times by the actual input energy of 100 joules, gives us 10 joules. So that is going to be just the useful energy. So what we then need to do is remember to calculate the wasted energy. You take the input minus the useful, and that gives us 100 minus 10 as 90 joules of wasted energy. One way we can represent these energy transfers is through the use of a Sankey diagram, which hopefully you encountered at Key Stage 3. And the key thing to remember here is that the width of the arrow shows the amount of energy transferred. So if they were to ask you to draw one of these Sankey diagrams, they would again give you a pre-printed bit of graph paper so that you can pick a scale easily. So make sure that if you do get asked this, that the width of your arrows is representative of the energy transferred. Hopefully at the end of this video you can calculate energy efficiency for any energy transfer, and you can explain ways of reducing unwanted energy transfers.